Now we're going to move on and we're going to talk counting rules. And counting rules are kind of fun. Sometimes they take a little bit to get the hang of, but maybe I'm trying to make a code for something and that code requires that I choose one letter and then I choose a single digit number. And I want to know how many possible codes I can create like that. Okay, or maybe I want to flip a coin and write down what happens, and then I want to roll a die and record what happens there. And I want to know how many possible combinations I can get from that. Okay. Or maybe I'm back to a code and I want to make a 3-letter code, but I can only use the letters A through E. And I can repeat if I want to. So like AAA is one code and AAB is another code and ABA is another code and so on. Okay. Or maybe I'm going to make that 3-letter code and my letters can't repeat. So if the first one is A, the second one can't be A. So I might say ACE. Okay. And made all of those, and that's different than CAE or EAC. Okay. And I want to know how many possibilities I can to make that. If we have two events like this, the nice thing in these formulas are in your book, but all I have to do, okay, and I kind of make myself a little template. I have a 2 or a letter and then a number. Here I'm going to do 2 things. I'm going to flip a coin and then roll a die. Down here I'm going to make a 3-letter code. Here I'm also going to make a 3-letter code. Okay. All we have to do is figure out how many ways we can do this. Okay, how many letters are there in the alphabet? There's 26. And then I say, well, how many single digits? So that's 0 through 9. And if we count those up, there's 10 of those. And we just multiply them together. That means there are 260 ways that I can choose a letter and choose a digit. Okay, and so if I have maybe 200 students in my school, their locker code could be A5 or B9 or some letter and some number, and there's 260 ways I could do that. If I'm going to flip a coin, we know there's 2 possible outcomes. And if I'm going to roll a die, there are 6 numbers that could come out of that. And so I could have a head and a 1, a head and a 2, a head and a 3, clear up to 6. I have a tail and a 1 and a tail and a 2, and all of that clear up to 6. Okay, altogether there's 12 different ways I can do that. Okay, 12 different outcomes from that event. If I'm down here to putting 3 letters in a row and it says it's okay to repeat them, that means I have 26 letters in the alphabet, and then all 26 of them are fair game for the second, and all 26 of them are fair game for the third. And so I'm going to have a whole lot of, that's a lie, because I didn't want to make a number that big, which is why I said we're only looking at A through E. Okay, this is what happens when I change my game plan. I'll call you. Okay, sorry for that interruption. I had to take a call. We're trying to multitask tonight. So my 3 letters are only A, B, C, D, or E, which means I have 5 choices. And since I can repeat, I have 5 more choices, and then I can pick any of those 5 numbers again. So there's 125 ways I could make a 3-letter code out of the letters A through E, being allowed to repeat. But maybe I'm not allowed to repeat. So I have 5 letters to choose from for my first one. And then once I have picked A, B, C, D, or E, that just leaves me with 4 remaining for the next digit. And then once I've set those 2 already in place, then there's only 3 left on the list from there. Which means if repetition is not allowed of my letters, then there's only 60 possibilities, less than half of what I had when I could repeat. Okay. we have a situation here like this where we notice we went from 5 to 4 to 3. Maybe I had a 5-digit. I was making a 5-letter word using each letter only once. 5, 4, 3, 2, 1. Something that's going to happen a lot in our counting rules is we're going to use what's called a factorial. Okay. When we see factorial on our paper, it'll be an exclamation mark behind the number that I'm working with. Okay. When I see a factorial behind the number 3, for example, it means I'm going to multiply 3 times 2 times 1. Okay. If I want 6 factorial, that means I'm going to start with 6 and multiply it times 5 and then times 4, and I go all the way down to 1. Okay. 12, 24, 20, which I think, if I remember right, is 720. Okay. Now understand that with factorials, our numbers can get very large very quickly. 12 factorial would be 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And I couldn't tell you what that is off the top of my head. Okay, when we move on to the next video, I'm going to go ahead and shut this one down and start a new one. We're going to talk about permutations and combinations, which involve factorials.